attracts only a few hundred attendees, and it has a single track program in one room. In this My Technical Talk, Arnoud and Jean will distill the key takeaways from the event, summarize core technical insights, they spotlight emerging trends in the Linux kernel and embedded system communities. Arnoud and Jean also together co-authored two articles that appeared on the blog of the Mind website just last week. I would also like to take this chance as an opportunity to announce a few more blog articles. The first one that we expect to publish next week is about the implementation of AB updates using QEMU and Buildroot, written by Colin Vraag. And then there's also an article in the pipeline about a port of the Doom game engine to the STM32MP, which is a dual-core Cortex A7, a small embedded device, but running the Doom game engine. So I now give the word to Jean and Arnoud, who will talk about the Embedded Recipes conference in Nice of a few weeks ago.
Okay, thank you, Rido. So, hello, I'm Jean. Presenting this thing with Arnoud. So, right, let's go. What was the conference about? Really nice conference, really nice organization, and in a nice format, I would say, because it's small, 100 plus people, but influential, because you have key people from Linux kernel, Yocto, Buildroot, V4M2 and those things. So really influential people. So that's a great place to meet people, to ask questions, to ask for feedback, to ask for if you can contribute. Really nice. So today's presentation in a single room, so easy to follow with breaks, of course. There were 19 presentations given in the 2 days. Here is the URL to the website, so you can find a lot of information there, speakers, the slides, the video, the bio of the speakers, and a nice gallery. You will see I have a few pictures next. So this is the intro and conclusion at the same time, let's say. So nice team, nice venue, nice presentations. What else? You can see nice room, fully equipped, audio, video, camera, streaming, really nice. Highly technical content, so because you have the main maintainers, contributors, it's really technical, so you can really deep dive into topics. Topics were also various, so from Linux kernel, Yocto, build system, CRA, you know, all those European Cyber Resilience Act topics, a bit about 3D, and yeah, various things. Next one, you can find the technical blog that Arnoud has written, one article per day, so really detailed a view of every presentation. And this presentation is about a summary of every talk, right? So let's start with day 1, and I will give the word to Arnoud, then I will give the day 2 next. Okay?
Yeah, as usual, we are going to go over the most interesting talks, but because this conference is so small, all the talks are interesting, so we're going to go over all the talks of the conference, very briefly say what was said in it, maybe some main conclusions, and there are links to slides and video if you want to find out more. Because the subjects are quite diverse, please ask any questions right away, don't wait until the end, because yeah, otherwise we lose the train. As Jean has said, the topics are generally very in-depth technical. The first two, however, are more well, organizational, let's say, or more about how to do open source software development or software development using open source. So the first one is from Greg Hartman, who is the maintainer of the stable kernel tree, or one of the maintainers, and is also involved in several things related to that, including CVE tracking, and he's also in the CRA, I forgot what it's called, a working group, an official working group from the EU that defines standards around CRA. So in this talk, Greg took the point of view of an open source developer and what it means as an open source developer, what kind of impact that CRA has on you. The thing is, CRA requires you, if you make a product with software components, which includes software itself, and if you sell that in Europe, but selling also includes giving for free, then you have obligations in terms of security. And for an open source contributor, that can be an issue because it means that just by contributing, you could somehow have more obligations than you would think in first instance. And so this slide I selected, it's actually not from Greg himself, but from somebody else who summarized a FOSDEM presentation of 2 years ago, but it's still up to date. So it summarizes when you are considered a manufacturer, so when you really do have responsibility, and when not. And basically the bottom line is it's not that bad. So it's only if you're directly monetizing a project, and if you're not a person but a legal entity, then there is any risk being affected by this. And then there's a special status of open source software stewards, which is a legal person that has as its role supporting open source software. But yeah, look at the talk for more details. He touched on some other subjects as well, but I think this is the core message. The main message was it's not that bad. For an open source developer, you're not that impacted. Let's move on to the next talk, which was also more about organization, from Marta, also a very known figure. She gives trainings in security in open source. So she basically gave an overview of everything that is going wrong in companies that use open source software to build products. So she identified a few domains where things go wrong. So there's the open source aspect itself, like licensing. There's the lack of maintenance cycle, like you keep on using 10-year-old versions of software, as we have seen recently with, well, for the Mind people, that has gone around an example of an payment terminal, which turned out to have a build root version of 2010. Then that there are more and more devices that have internet connection and that have that contain open source software, and then the push of cost reduction, and which includes also less developers involved. And so she foresees that these problems are going to be forced to go away, amongst others, due to CRA. But CRA only really comes in force in 2027, but there's already actions we can take now, and she has some things she mentions there, like make sure that you can update your software, and that includes all the software, so not just your application software, but also the OS and maybe the bootloader. Care about your dependencies, so there is not just the libraries that you consume directly, but they themselves also have dependencies. So all that ecosystem, you have to review it and not just blindly consume it. And the important message there is all your dependencies, you have to choose to, you basically have to maintain them for 10 years, or if you don't want to maintain them, you have to be ready to replace them with something else. And then the importance for the maintenance cycle, update by default. So don't do updates pushed by CVEs or something, but just do updates continuously so that it's in your flow, and that that you're used to doing that. And then learning is also an important thing that she mentions. Of course, since she gives trainings, it's an important point for her. It was a rather interesting talk, actually. So this one I think is useful to watch, because it touches on some valid points and gives some a practical approach to tackle them. I'm going to try to apply this in bite slice. So now we go to the technical talks, the really technical ones. First one is was quite big, a bit of a challenge to follow. So basically, Alexei, he talked about the problem that he had and some generic solutions that he has for that. So the problem that he had was that he needed to debug issues with some device encountered in the field, and that led to the device crashing and maybe even coming back without, completely broken. So to be able to debug something like that, you need to have some tracing. Now, if the problem is that the device crashes, for instance, because of a power supply failure, even though it's battery operated and so on, then you need some tracing of that power supply failure. And so he has a number of contributions he did to help with that. First one is under voltage detection in the regulator framework. So lots of regulators can detect when there is an under voltage, so when the voltage drops. And at that point, you still have a little bit of time that you have enough power to do something, but you can expect that the voltage will drop completely after a short time. So the first step that you need to do is detect it. And then there's two things you want to do. You want to take action on the one hand, but also log the event. So for taking action, he has a handler for that under voltage detection that does a fast shutdown of the eMMC. So that the promise with eMMC, if you remove the power supply very quick, suddenly, and the eMMC is doing right at that point, it can get corrupted completely. So to avoid that, he does this fast shutdown. And for storing it, you can't store it in the eMMC, obviously, because that one is shut down. So you need something else. And there's a special chip called a power state change reason recording chip, which is basically a small NV memory. And he created a new framework for that type of chip. And then he also did part I didn't really understand is added a property in device tree for critical regulators. Basically, regulators that if they fail, they kill the CPU. I'm not sure why that is useful, because if that regulator fails, yeah, CPU dies. So what can you do, right? This talk was interesting to have in the conference because it brought up a lot of things that were like his specific use case, but where other people had thoughts about how can this be done more generically, how can it be used in my specific context. And it's innovative. So I say innovative there because it's stuff that doesn't exist in the Linux kernel or in any other operating system that I know of. And so it needs exploration of, okay, what are the good solutions here? So it's really interesting to see this kind of thing happening in the Linux community. It's stuff that gets solved in custom ways in many products probably, but it's nice to see it more generically. Next talk is technical, but it's actually focused more on describing Bluetooth and Bluetooth low energy audio, which is a complicated beast. That's why I put the picture on the top right there. Bluetooth consists of Bluetooth Classic, which is the old stuff from the 90s, and then Bluetooth Low Energy, which is what most devices are using, most newer devices are using. But audio has been a problem for low energy for a long time. So it's only since 2020 that there is a standard for low energy audio, which has implications down to the PHY layer. So it's you really need a chip specifically that supports it. It's not just protocols on top of it. And audio is not a simple thing because there are many different profiles, as it's called in Bluetooth, involved in it. So there's not just audio transport. So there's the basic audio profile, but there are also like media controls or call controls for phones, volume controls. So that's one aspect of the complexity. And the other aspect of the complexity is the need for being bidirectional. So in the classic profiles, that has always been a problem. So you have, for instance, A2DP, which is a high quality audio profile, but it's one directional. And then you have the headset and phone profiles, which are bidirectional, of course, but they don't support high quality codecs. In LE audio, that is solved. And then he went on describing a bit how this is implemented in PipeWire or being implemented by PipeWire because it's not complete yet. Because of all the different profiles that are involved is complicated, and because some profiles are only tangentially related, like the telephony and call lists and stuff like that. So it's also not very clear, does it fit in PipeWire or not? But they're getting there. The details of how it is implemented in PipeWire were not so interesting for me. It was interesting for me to see how it's what the difficulties are, what this complicated beast is, and why it's not. So it's already 5 years old, this standard. Why it is not implemented in PipeWire yet? The next talk,
Arnold, just to go back to the previous topic because I'm thinking about it. No, the one before, about the kill switch of the CPU. I'm wondering if it doesn't want to do that because if you have a little drop of voltage, for example, but the power supply is coming back fast enough eventually. The purpose is just to be sure that the CPU is and the complete system, in fact, is in a complete working state without, it was without enough voltage for some time, and maybe some components are not behaving correctly. And we want to be sure that, if the power supply is coming back fast enough, we don't have these strange behaviors, I guess.
Yeah. Yeah. Okay. So So like that you get from these critical resources an early signal that can then be used for something.
Yeah. Yeah, just to be sure that, the system is reset and we are sure that it's working in any case and we don't have strange behaviors if something is happening in the meantime between the signal and eventually the system shut down. I don't know.
Yeah. Yeah, I also don't know. Or I didn't understand from the talk. This one was nice conceptually, but the talk itself was, for me, quite confusing. So it was not easy to follow. So basically, the problem that Devarsh wants to solve is during the boot process, the GPU in the frame buffer and everything is reinitialized quite often. And the result is that it's not possible to show something on a screen early on and keep it there until the actual application starts without a lot of flickering or like the random pixels changing or the screen going black for a while. So that's what the problem he wants to tackle. I'm not sure why TI is doing that. Maybe to demonstrate to their customers that their platforms can do that. But, yeah. And so the solutions are not surprising, but complicated. The solution is to not reinitialize GPUs in the different boot stages. And the same for clocks and power domains. And specifically for clocks and power domains, the additional problem is that the kernel during boot up, so even if it detects that the clock is already running and doesn't need to be started, it will also see that there is no consumer of that clock and then turn it off anyway. So specifically for a frame buffer, the driver for the frame buffer will be is probably loaded later than the driver for the clock. So when the driver for the clock is loaded, it doesn't know yet that the frame buffer is actually using that clock, and so it thinks that there is no consumer for the clock. It's only when the frame buffer driver is loaded that it will register itself as consuming that clock, and same for power domains. So he has slightly hacky solutions to just leave clock and power domains on. And then the other problem to tackle is that, there is already something on the screen. You need to know which memory area it is and not overwrite it. So the pixels that are gone there, that is due to this memory area being reused for other things, and that is then reflected on the screen while it's actually not considered a frame buffer anymore at that point. So the solution for there is to pass over the different stages, these reserved areas for the frame buffers. I alluded already to it. All the solutions he has, it feels a bit hacky, but I guess is the only way that you can do that kind of thing. And the same solutions are actually also used for faster boot. So peripherals which are already initialized by the bootloader, avoid reinitializing them in the kernel. Then you boot faster because you do less work in the kernel bootup. Next talk, this one I understood even less of. So it's about functional safety in Linux. The basic idea is that you is to be able to use Linux in something which has safety requirements, like an instrument cluster in a car. The examples that he gave are not super realistic. But so basically the idea is that instead of the thousands of microcontrollers you have in a car nowadays, to reduce the number of microcontrollers and to have several functions on the same CPU. But then if there are safety functions in there, yeah, such a big CPU, Attila?
Not a question, but to just an addition. It's already in the a trend in automotive to reduce the number of processors into clusters. Of course, they are trying to do it as carefully and logically as possible, but yeah, it's just already a trend to like have less computers and map more applications to them.
Yep. But so the if there are safety, well, if there are different functions with different safety requirements that are combined on a single system, then you have to make sure that they are isolated from each other in a way that they don't interfere, or well, the non-safe parts can't interfere with the safe parts. And what Red Hat wants to do is to use Linux as the lower level, or well, maybe not Linux, but KVM as the lower level framework on which this coordination between safety levels is done. It's also not targeting the highest safety level. It's so ASIL-B here, that's the second highest. I don't think actually that will run still on a Linux box. It's more for ASIL-C and ASIL-D. Well, the thing is that he well explained the problem, but didn't really go into solutions. More that there are remaining problems in isolation. Even if you trust the kernel and can certify the kernel, then still there are still things which are not isolated, like the memory manager can cause interference. Give other examples. So yeah, not yet there. Jean-Antoine?
And there is no real-time constraints about this kind of safety process?
Real-time contracts?
Constraints.
Constraints. Yeah. So the safety things normally have real-time constraints, and real-time constraints, and that's one of the reasons that you shouldn't have interference between the different safety levels or the different applications. Because if there is interference, then it can violate time constraints, even if the safety application has been validated to satisfy the real-time constraints in isolation. If you then combine it with something which is not validated at all, and the isolation is not good enough, then you can violate the real-time constraints. Next talk is the safe update of firmware blobs. The concept I find very interesting. So the problem is that you have now more and more firmware blobs or other pieces of firmware in addition to the kernel that need to be loaded on a system. So this includes, for instance, the DEE, but also like DDR training blobs and stuff like that. And these are loaded by the bootloader at the moment. Well, they have to be loaded by the bootloader because they need to be before the kernel boots. The problem is that the current flow is that you have a ROM boot and then TFA, and TFA loads those firmware blobs. TFA is an example on ARM, but it's the same principle on RISC-V. And then you have U-boot and then the kernel. But the update system normally uses U-boot as the thing that switches between A and B, which makes it difficult to update those firmware blobs in a consistent way. In particular, if you want to make sure that it's updated consistently with the kernel, because like the SMCI and the TEE, they may have new APIs that are used by a newer kernel. And so if you update the kernel without updating the SMCI or TE, then things are not going to be to work. So you need an AB update system that includes the firmware blobs as well as the kernel derivatives. There are basically two paths you can take there. There is either you make sure that the AVA can do the AB updates and is aware of everything, or you throw out the AVA and use U-boot for everything because U-boot already does the updating. Marek, because he's working mostly for Dinks. Well, actually, he's now independent, but he used to be a Dinks employee. Yeah, he goes for U-boot, obviously. There are good reasons for that as well, because you anyway need U-boot to do the first development on a device, and the community around TFA is not. Well, there's not much of a community, and U-boot is more than just ARM. TFA is purely ARM. So yeah, those are reasons to go for U-boot. And the idea is to put everything, so the kernel and the firmware blobs, in a single feed image, which can then also be signed as a whole, and it really simplifies things a whole lot if you can do that. And the way it works then is then to do ROM boot, go to U-boot SPL, and then optionally still go to U-boot, but actually you don't really need the full U-boot normally. And then U-boot or U-boot SPL has to be able to load the firmware blobs and finally jump to the kernel. And so he went into some technical details about what the problems are with being able, I mean, what you need to change to be able to load firmware blobs. Yeah, which is basically bringing some of the TFA functionality into U-boot. It was interesting, pretty in-depth technical. And of course, he just implemented for one platform. This is all very platform specific, so you have to redo it for all platforms that you want to support. So yeah, worth watching in my view. And I think then we come to the last talk of the day. Yeah, that's the talk about AI. This is the only talk about AI in the entire conference. So we are not quite on the hype train yet, but we're getting there. But it was a talk which was not too hype. So it's clearly somebody who believes in AI. So he said like that using AI, he can reduce his development times with the order of magnitude. I think that's maybe probably in his specific case, because he's basically doing. So he works as a volunteer for SaveMyPlanet.org, where he does all kinds of stuff which is not his normal work, which means you have a lot of ramp-up time normally to get anything done. And that's, I can imagine that is something where AI can help a lot. So the talk was mainly demonstrations of how he used Claude to do some small changes to existing software. And he's basically highlighting specific use cases where AI or Claude can help. So it was, for me, really interesting to see a more realistic view, not too hypey, about how AI can be used for software development. If you want to be convinced, so if you're a bit skeptical but not too skeptical, then it's a really interesting thing to watch. And that concludes the first day of Embedded Recipes, and it also concludes my part of the tech talk. And now Jean is going to take over for the second day.
All right. Thank you, Arnold. Let's go for the day 2. So after day 1, obviously, we've had really nice social event on the beach in Nice. Yeah, could be worse, right? That was fun and really the occasion to discuss, to make contact, and to talk with maintainers, developers. That was really interesting. So after a good night of sleep, let's go for day 2. First talk. So there have been 11 talks on day 2. So let's go. First one, Anna-Lena from Innovex was talking about TPM. So it's about trusted code, managing keys, crypto, security, basically. So what is TPM? It's hardware or software reference implementation. It does implement cryptographic operations like random number generator, key generation, crypto algorithm, but really important to securely store keys. Basically, it stores private keys, persistent seeds, we'll explain what that is, and PCRs. So with those mechanisms, you can implement a full secure boot and leave the private keys where they should be, where no one can access them, and just communicate from your OS or applications with the TPM that way. Lot of details, lot of stuff there. The slides are really good, and the presentation as well. So I invite you, if you want, to check the slides or video. Yeah, Yocto implements this already, so but only for UEFI systems. So quite interesting, but really in the security domain. Right. Next one, SteamOS. It was a bit of video gaming. Well, quite fun as well to see Olivier just playing his whole adolescence and teenager time doing Half-Life on Windows. And then he later realized, oh, why not Linux? Let's do it on Linux. It has advantages, as you know. So from there came SteamOS in 2013. SteamOS is a general purpose OS, so you can install this on your laptop if you want. And what Igalia, the company of Olivier, is doing is to improve SteamOS, contribute SteamOS. And the talk was about two topics. First, it's a special scheduler that is not fair, but it's about latency critical applications or threads, like the one that need to render the frames of the game. Takes more importance because it's more critical. So he gave a really nice demo of the regular scheduler when you see the game playing, but then when the CPU is loaded heavily, you see a lot of flickering, and timing is not good. The frame rate drops, but more importantly, it's hacky. The image is choppy. Then in runtime, real time, it just enables a new scheduler, and you see the same game, same use case running brilliantly. No real hiccup. Although the frame rate drops a bit, it's still playable, no problem. So really nice demo to see how it's done. And second topic was to implement a C group policy for DRM on the GPU. So you can also control how the GPU is scheduling tasks and exchanging data with the CPU. That's yeah, it's a lot of technical details. I will not discuss about them here. Also, a small topic was disk encryption. They want to retrofit disk encryption to SteamOS. Lots of technical details there. One really good thing about Ikalia is that they upstream first, so it's really first go to upstream so that everybody can benefit from there. So maybe we'll see those scheduler and so on in mainline or in other distributions. Let's see. Right. Next, really good talk from the name Zimuzo. Yeah, 4Z in one name. Who can beat that? Really cool talk. A lot of interactive demonstration about Perfetto. So Perfetto is profiling tracing for kernel and Android. So it's like ftrace, kernel shark, but next level from Google. They started from scratch. They didn't even know kernel shark was there. They just started their own stuff. And it's quite good. It's really good because Perfetto is a set of utils that you run on the target to gather some traces from CSFS and so on, everything possible. And it stores that in a SQL database. You can also get Android traces like window manager, services, ADB, events. So that's about what runs on the target. And then you have the web UI. You can go to perfetto.dev and you will see the UI in your browser directly rendering stuff. And then you can load the trace you just generated and do it from the browser. The really good thing is that no data from your trace goes to Google. It's all locally handled in the browser itself. Quite magical. Supports a lot of formats. You can use Android as well as Linux standard tracing. You use config file just to define what you want to gather, more or less details, buffer size, type of events, a lot of stuff. Zimuzo gave a lot of demonstration, different configs. It was really cool. And the UI is really nice. You can do much more than with the existing tools. Why? Because with SQL database, you can correlate events. You can link tasks to events. You can see who woke up which one, and so on and so on. It's really powerful. And the SQL console allows you something really special. It's you can isolate one rare event from a huge trace. So you could inject events from your application if you detect a problem, plus all the trace in the system. And then you can run a real SQL query, like SQL, select from table, blah, blah, blah. Huge query, and you get the events. And from the events, the UI is updated directly. So you can have a flame graph of rare events and so on. It's really, really nice. That's about this talk. So if you want to see the demo, let's go to the video. It's really interesting. Right? Lead camera, something from IDs on board, a bit of Belgian stuff there. So Kiran gave what is lead camera and what is going on with this. So they are really active. They are developing a lot of technical details. Basically, lead camera allows you to abstract the image processing chip. So basically, one physical camera that you can use from multiple platforms, multiple components. You can have native, Android, and so on. So quite cool. Really used everywhere. So you can look every project that uses video camera. You can make sure it's with camera behind the scenes. Now they are really active, trying to release 1.0 with a lot of new changes. I did not list them here. It's a lot, but you can find the slides and the video, of course. Okay. Then that was really interesting. That was for me the really good talk. Really deep technically, but so easy to understand because it was really given in such a way that you could follow easily. So John Ognes made it really nice. So what is it about? Linux 6.12 has preempt RT built in. So that's a big news. 25 years of work from the RT team. No, it's in the kernel. So does that mean your application, they go real time magically? Of course not. Would be too easy, right? So John gives a bit of a checklist. What do you need to do to make it? So first question, really important. Do you need RT? Do you need it? Most people, they believe they need it. They don't. They try to enable RT on, let's say, Firefox, the browser. There's no sense. The system will not be faster. It will be more deterministic to some events, but it will not be faster. So first question, do you need RT? If yes, where do you need it? Which application, which thread? Don't put RT stuff in a UI, for instance. There's no sense. So that was really interesting to hear about those considerations. Then more technically, I listed a lot of stuff there. You need memory locked. Make sure you don't page fault, and so on. You need to set the priorities right, so you don't want to interrupt the RT task with a UI task, for instance. It looks easy, but it's really complicated in real life. And then the big thing is a lot of interfaces in frameworks in the Linux kernel. They are not real time, like timer FD and the POSIX timers that we use all the time. They are not real time. So you better use clock nanosleep instead with monotonic timers. So that's pretty interesting to discover those points, right? Also power management, just put it off because it will interfere with the reactivity and the delays to switch frequencies and so on. So in short, it's not easy, but you get a checklist. There are people helping you to if you need and so on. There are tools as well. So fascinating topic, I think. Right. Next one. I gave a presentation there. So I presented something a bit different. It's not about kernel and Yocto and those. It's a bit about tinkering with machine and finding the best software to run on it. The big thing is doing open source from end to end, meaning open source from the hardware, schematics, maps, and blueprints of parts, and so on. Then software, of course, so the firmware on the machine, the host tools, so and the models. You can also find models online. So the idea is to make it fully open source. So you just decide what you run, and it's also cheaper if you want to do it at home in a hobby or even in a light industrial environment. It's really viable to do so. So two parts in this talk. So first, 3D printing. It's well known, really. Everybody knows that. Everybody uses it. It's really good. You can do it, no problem. And then second part, CNC. CNC is a bit more industrial, less known by everybody. So the idea there is to adapt the 3D printing resources, schematics, firmware, code, tools, and adapt this to the CNC world. So how to do that? So in the machine itself, put a board that is compatible with 3D printing, because it's more or less the same machine. Machine is stepper motors, basically temperature control, display, buttons. It's similar. So let's use it put a 3D printing board in a CNC, adapt the firmware, it's really easy to do, and then use the OS tools. The problem with CNC, you need a specific CNC/CAM software, and their FreeCAD today is really good to do it. So you can do the full solution. You can do it fully only with FreeCAD. It's really good. That's about it. Just to say that CNC is doable. It could be a really good solution for small companies doing basic light industrial, which means it's not the Formula One part that you want to make, multi-axis, multi-tool, and so on. It's the light CNC, meaning engrave, control panels, cut plexiglass, metal, wood. It's really easy to do. That's about it. The slides and video are available. Slides, there are a lot of images, screenshots. That's it. All right. Then Tim Bird of Sony, that you know, gave us a really interesting talk about the status of embedded Linux. Lots to say there. So it was a lot of news, numbers, stats, and also fun facts. So really nice to follow this one. A few jokes here and there. It always helps. Like Thomas Gleixner handing over a pull request printed on a paper with a ribbon and so on to Linus Torvalds about the art stuff. It was quite fun to see pictures of that. So we discussed a lot of details, and to conclude that with time there are a lot of good things happens in Linux kernel, but also there are worries like AI is accelerating all the time, faster and faster. So for instance, some AI automated testing setups, they reported thousands of problems at once that no maintainer could follow, kind of stuff. More worries than real problems. The maintainers, they are aging as well. So let's try to find new resources there, young people with new ideas. So yeah, Tim Bird said he has now 8 grandchildren, so time to take care of them. It was fun. Yeah. And Tim gave also closing game stuff I will talk about. That was really fun as well, but that's for the last one. Okay, though something about the ability to do system update with Yocto. It's fully integrated in Yocto. You can download, install system updates using this mechanism. You can just script what you want to install. There is a mechanism to do A, B, C, D, whatever images you can install. It was quite nice to see. It's work in progress, but it works already with some limitations, like Delta updates. They would like to do it, so it's coming, I guess. Yocto is not yet fully integrated, so there are some scripts you need to write yourself, and only works on the UEFI stuff. But yeah, it's promising. Although in a real production environment, it's mostly custom solution to do AB updates of all the components. But let's try to merge all of this in such a tool. Let's see what the future brings there. Right. So then we had Valerio from Belibre talking about Zephyr. So they only talk about Zephyr. There should be more of them because it looks really interesting. This Zephyr system that supports all the CPUs you can think of. It's fully featured kernel kind of kconfig and device tree stuff. Supports languages for application and real build system. And the crypto stuff was the topic. So what is it about? So it's doing implements a lot of crypto algorithms, TLS, and so on. It has a secure boot. It has secure storage. No hardware acceleration for the moment. But then you cannot store secure keys, for instance, with this. So how do you do this? You do it in the ARM TF. So it's not TFA, it's TFM for M core, same stuff. So it's the ARM TF runs in trust zone environment, and you can exchange keys with Zephyr, like you do on Linux with Opti, for instance, and ARM TF. Same stuff, but for Zephyr. So quite interesting as well. I didn't know much about Zephyr, so that was an occasion for me to look at this and find it really interesting. Then recent changes in Yocto. A lot of stuff to say here. Listed summary, but I will not go through all of this. But it's from Antona of Butlin. He is the documentation maintainer, so really nice person, and a lot of information you can get from Antona because he's writing stuff. He knows a lot there. Yeah, just if you are interested, just look at the release notes and this presentation. That there is a lot there. Right. Next. What's the last one? I3C. Is it better than I2C from Wolfram Renaissance? So I3C is the new I2C. It's better in a lot of ways. Still, it's backwards compatible. Uses 2 wires, including 2 signal interrupts. On I2C, you need extra wires. I3C supports this. You can go faster, like up to 12.5 megahertz clock, dual rate DDR. So it looks like SPI in terms of speed. You could put small display on it. It's unpluggable, so quite interesting to see. And the driver is going well. So there are already 4 drivers, if I remember correctly. That's easy, but the problem is in the hardware availability. Looks like it's too early to use it. So devices are hard to find. They don't work correctly. And the hardware tools, so to analyze, they are not really easy to find, or they are super expensive. So there was a discussion about hardware and software. It's quite interesting to see. So let's see what I3C brings in the future. Looks promising. Okay. Then a bit of fun with the closing game. That's always really nice to see. Team Bird, with his Hawaiian, penguin shirt. A lot of jokes, a lot of weird questions you can't imagine. I don't know if there is a video of that. Maybe yes. By the way, you can find the whole day video on YouTube. And if you look for Bay Libre, you will find a video for day 1, a video for day 2. I guess this is part of day 2. So about the rules of the game. So we start with this game is unfair. So you know what to expect. And it was fun. And if you win, you have a prize, a small embedded board. If you lose, you get a candy. Cool. I got a lot of candies. So that was fun. And like you see in the picture, it was the famous what is it, paper, rock, scissors game with a full audience. That's quite fun. So that was closing the 2 days of presentation, and yeah, that's about all I wanted to say there. One thing is that was a great place to discuss with maintainers and people that do the stuff. They really do it. Like if you have a USB question, go to Greg KH, just ask him, no problem. You have an Android question about performance, go to Zimuzo. They are there. So if you go to this conference, it's the place to connect and to ask questions and to see what's happening. Right, that's all I wanted to say. I sped up a little bit so that we are more or less on time. So Other questions, remarks? Don't hesitate. All clear.
If there are no questions. Okay. Anyone who has questions? Thank you, Bram, for the applause.
Thank you.
In that case, I would like to thank Jean and Agnat for a very interesting presentation. It's actually, for me personally, this is actually a very convenient way to learn about a lot of technical and trendy topics without having to spend 2 days to attend the conference. So it's very convenient, in my opinion. I would like to thank you again for this very nice summary of all these different topics. And thank you, Heiko. Yeah. And then I would like to announce we will have no Mind technical talks during July or August, but we will be back in September with a new technical talk that's still to be scheduled. And please subscribe to our LinkedIn channels. Please check the blog for the summaries that Jean and Agla provided about these talks. And then I would like to thank everyone in the audience for being here. And we would like to welcome you again in September. Thank you very much, guys.
Thank you. See you soon.
Thank
Let's
you.
do it for the next
Goodbye.
conference.
Bye.
Bye-bye. Thanks.
Thank you very much.
Perfect.